Okay, so chapter number 2, we don't have much new stuff in chapter number 2, flow of control, because it is very similar to what we had in C. But there are a few new stuff. Let's see what they are. First of all, let me try to İlhan, sen bir şey, instruction falan göndermedin hiç ya, ben seni gönder... Efendim? Kime gönderdin? Tamam, okudular Seher. Tamam, oldu. So read your instructions about the attendance. We are going to take the attendance online. You are going to use your cell phones to write your name to a spreadsheet, but I didn't read the instructions. I don't know what the instructions are. So the attendance sheet will be available in 15 minutes, I don't know. So you are going to write your name there, but you should log on using your school email, okay? Do not log on using somebody else's, because we are going to check who is writing where. And I'm going to read a few names at the end of the lecture to see everybody is here. Okay? So where is the attendance instructions? It is in the Teams page. So I am not online. Do not write anybody else's name, okay? We are checking what login name, what username is being used to write it. I guess we are now. Am I online? No. Anyways, okay. I'll call Ilhan. He'll handle it. Okay, so let's go back to our slides. We were saying that in this chapter, nothing much new. We are going to see the control structures like the if branching mechanisms, if else switch, nested else, if else, and loops, and maybe something here around here. What's going? I don't know what's. I think my battery is dying. Use a new battery. It looks like it. So this is bad battery. So we are going to do this. At the end of this chapter, we have the introduction to file input output. Well, I mean, you know how the files work. I'm just going to tell you how we do that in C++. Okay, let's start. First of all, let me make this definition. Let me make this definition of structured programming. Well, you know what's structured programming, but you didn't know this name. In C, what we do is the discipline that we follow in C is structured programming, okay? Structured programming says that you should always write your programs this way, okay? You write one statement after another statement and an after statement. It is called stacking. This is one way of putting together statements, okay? For example, you will say integer a, then a gets the value of 2, then you would printf something something. So I am doing the statement and statement and statement. This is called stacking, and you are allowed to do this. There is no problem with this kind of a program writing approach. And you can think this part like a box. There is one entry and there is one exit. Okay, there is one entry and there is one exit. The other structure that you can use is the condition. It's like this. Okay, you may say if a is equal to b, then do this statement, statement 1, else do statement 2. Okay, this is another way you can write your programs. Okay, conditional statement, and again there is one entry and there is one exit. Okay, and the third one is okay, this kind of a statement, a loop statement. Okay, you will say while a is less than 7, do this statement. Okay, statement 1. So it is in a loop. It continues to run this statement until this condition is met. Okay, so there are 3 ways that you can put statements together. Other than these 3, you don't do anything else. Okay, and these 3 is enough. These three statement types are just enough for you to write all types of programs. This is called structured programming. Okay, well, you might say, how am I gonna make compound statements in a condition? Well, the thing is this. This box becomes a single statement, and you can put this box either here or there, or this box becomes a single statement box, and you can put this box in here. So you can combine all of these 3 stuff together to write complicated, more powerful programs. Okay, this is called structured programming, and in C we did this all the time. We wrote our programs, we wrote our statements one after the other. Okay, what's going on? You have a problem?
We couldn't edit the document through mobile, but
What?
we couldn't edit the attendance list through mobile, but it works when we open it through the.
Okay. So if you have a question, just ask me, or maybe we will wait until the. Maybe we will. I mean, all people are okay with the attendance? Anybody having a problem? Yeah.
Problem.
What?
I don't have my phone there.
You don't have your cell phone?
Yeah.
Really?
Yeah.
Okay. Maybe. What other problems? What? What? What are you saying? I'm not. I say it louder. Say it louder. Can anybody understand what he says? He's talking about his first attendance. We were not talking about first attendance. What?
Says this sheet is protected. Some parts maybe we only have to change.
It is protected for many parts. It is only accessible for your slot. You are not supposed to change everywhere.
But I can't change mine.
Does anybody have the same problem?
Yes.
Okay. I will call Ilhan. Okay, he will tell. Okay. Are there anybody who doesn't have his cell phone with him, with her right now? Okay, I know what your problem is. Just one. Okay. So is it going to be this way all the time, or is it just you forgot?
I can get it, but for now, I don't know the attendance.
Okay, we will handle yours separately. Is there anybody who did the writing? Can anybody? You wrote your name? İlhan arkadaşlar accessible değil diyorlar ya.
Hocam
Switch.
G2 account'a
Gateway account'ıyla giriyor musunuz arkadaşlar?
şu ana kadar şey yapamadım.
10 people. Okay, try it again maybe a few minutes. Okay.
Ben süreyi uzattım hocam bu arada.
Okay, süreyi dersin sonuna kadar yapar mısın?
Tamam öyle yapayım.
Okay. Try it in 5 minutes. And we are going to handle your case later, okay? Okay, good. Because I mean, doing this paper thing is taking too much time, and it is very difficult to check. It is very difficult for us to check the signatures later. So I guess we are going to try it this way. Am I not connected to the internet? No. The problem is, I guess, if so many people are at the same time trying to access the document, the system cannot handle it. So it says the page is not accessible. Let me see what I am seeing. Okay. It's like homework. I cannot, I need to read the instructions first. Okay, I'm going back to the slides. I mean, for 1 or 2 lectures, there might be a few problems, but we will sort it out later. Okay, so this is called structured programming, and structured programming is what we did with the C programming language. When it comes to C++, we are going to do the structured programming. On top of it, we will do object-oriented programming, okay? It is a little bit, there are a few more rules with the object-oriented programming, but you simply follow the rules and that's it. Structured programming says that go-to statements are bad. You know, in C, the go-to statements are available, but we don't like go-to statements. Go-to statements, in the structured programming, it is always like this. You have your statement block here. There are many statements in here. There is a conditional maybe like that, okay? And many statements, and these are coming to the same place and etc. The thing with the structured programming is I can take this part and replace it with some other statement block, because all the programming parts, okay, all the programming parts are made of these structured programming rules. I can take one and put the other one in. They all have one input, one entrance, one exit, one entrance, one exit. This is the rule. If you use go-to statements, let's say I have this block and this block and this block. Go-to says that, okay, go to this part, and this one says that go to this part, and maybe this one says that go to this part. This is called spaghetti code, makarna kodu. With the spaghetti code, it is not that easy to, let's say, take this part out and replace it with something else, because it has many connection with the rest of the code. It is not isolated, okay? In the structured programming case, as I said before, since everything is made up of these 3 types of statement combination system, okay, I can always take that one of them out and replace it with this one, or take this one out and replace it with this one. They are all the same. That's why we don't like the go-to statements with the structured programming. Even though it is available, we say that don't use go-to. And in fact, there is another rule with the structured programming. Remember our break and continue statement in loops, in for loops, while loops. You remember these statements? We don't like these two statements either, because in the break statement, okay, in the loop, you say that if something happens, then just exit the loop, right? And again, in the continue, you say that go to the beginning of the loop from here. So you are adding additional arrows, even though I still have one entrance and one exit, okay, to this system. We don't like break and continue because it is kind of against the rules of the structured programming. If you have to, yeah, well, you use this. These are kind of control. They are not as bad as goto, but we don't like them. Try to write your code always this way. This, okay. So this is structured programming. And this chapter is all about structured programming, because I am going to teach you just branching mechanisms, which is the second box there, and the loops, and the statements taken together as the first rule. So we are not going to talk much about object-oriented programming in the chapter. Okay, let's move on. These are our operators, some of the operators available for us in C++. Okay, these are logical operators. What is logic? Logic is something. I mean, if we define logic in a very narrow sense, we say that logical variable is true or false. Okay, and that's why we have a new type Boolean. It's like integer, it's like double. There is a new type Boolean. We say that B1 is a Boolean, then B1 can have values of false or true. That's it. No other values. So in C++, we don't like using 0, non-zero to represent false and true. Okay, remember in C we said 0 means false, non-zero means true. In C++, the same mechanism is available, but we don't use it. Instead, we use Booleans. To work with the Booleans, we have these operators, okay? For example, this one says that if x plus 7 is equal to 2 times y, then this operator will return, okay, true. If answer is not character n, this operator will return true, okay? If this condition is met, this operator will return true. So these operators, logical operators, as the name implies, okay, they will return either true or false. So we don't have 0 non-zero stuff. We have it, but we don't use in C++. Okay, so these are the comparison operators, logical operators. They just return true or false. Special operators. Okay, so our need type bool, we talk about it. Values are either true or false. And through tables, you already know these. You know the AND operator, or operator, not operator. Okay, so the AND operator is double ampersand, or operator is double pipe, not operator is the exclamation mark. See, these are binary operators, two of them. They need two parameters, okay? They need true and false. So this one will return false, right? This is the AND operator. It takes two parameters, okay? So this is a binary operator, but this one, the NOT operator, it will take just a single parameter. That's why it's called unary operator. Unary operators and binary operators, and we are going to see these kind of operators a lot. In C++, C, there are many unary operators, there are many binary operators, there is a special operator, a Turner operator, and you know it, what it is, and we are going to see it in a few minutes. Okay, and while we are talking about operators, this is the operator precedence and associativity table. Precedence means that which one has the highest priority, highest precedence. Okay, so this scope resolution operator, remember when we said std cout a, maybe we didn't say it exactly like that, but if you did not using namespace std at the beginning of your program, you could use your cout like this. You are saying that there is a namespace std, inside it there is cout. I am going to use it with this operator. That's what you are saying. So this is an operator here. This is an operator here. Maybe use red. This is an operator here. Okay, it's called scope resolution operator. Of course, it's a binary operator because it takes two parameters. One is here, the other one is there. That's why it is called binary scope resolution operator. Okay, binary scope resolution operator, and it has the highest precedence. Okay, it has the highest precedence. So how many operators do you see in this line? I see two. Okay, one operator is this one, the second operator is this one. If I compare the precedence of these two operators, of course this one has a higher precedence. This will be done first, then this will be done later. Okay, so in the next group I have these operators, the dot operator. Remember the dot operator that we used to access the members of a struct, or the arrow operator. We use it with the struct pointers, and the array indexing function called post increment, post decrement. Okay, so a plus plus is post increment. Okay, plus plus a is pre increment. So it looks like post increment has a higher priority than the pre increment. So if you see something like this weird, don't do this. Don't write any code like that, but that doesn't mean that we shouldn't think about it. Okay, what does that mean? It means that it looks like postfix has the higher priority than the prefix. So it looks like this is going to be done first, right? Then whatever it outputs, this will be done later. Do you think this would work? Do you think this would compile? What does that mean? Remember the meaning of the postfix increment operator? It says that increment the value of a first, okay, but return the original value, right? You return the original value. So this one will increment a, and it will return the original value, but it is not returning a, right? It is returning original value. That means that it is returning something temporary, right? And you are trying to increment that temporary thing, which is not a very useful thing. Well, I'm not sure if this would compile, because since this is a temporary thing, incrementing a temporary thing is a bad idea because it is going to die anyway. Maybe the compilers are smart enough not to allow this kind of a statement. It may allow it for the integers, but it's not going to allow it for our classes, and we are going to talk about this later. Okay, so I just try it using the different compiler switches or different compilers to see what is going on, to see the results, and try to see what the assembly is producing for this kind of a statement. Okay, try to see what the assembly is producing. Again, don't write this in your actual code, but that doesn't mean that we shouldn't think about it. I mean, Let's see what's going on here. So the precedence of all these operators are the same. The precedence of all these operators are the same. So in that case, what happens if I write something like this? How am I gonna write it? Maybe I should delay this maybe I should delay this for the other operators. Okay, the precedence of all these operators are the same, and precedence of all these operators are the same too. These are again binary operators, binary not operator, binary. Sorry, these are all unary. They will take all single parameters. So this not here, it says not false. Unary operator. They are all unary operators. So this one is not A minus B, it is minus B, okay? So don't take this as like binary. Again, this plus, I don't think that anybody uses anything like this. A gets the value of plus B, right? It is available. We don't use it, doesn't make much sense. It makes sense to write A gets the value of minus B. That doesn't make any sense to write A gets the value of plus B, but it is available. So plus is available as for the unary plus and binary plus. The reference operator, we know this, that's the operator. This new, delete, these are some new operators for C++. We will talk about them. Again, all these operators here, they are the same precedence, okay? They are the same precedence. Okay, let's move on. Then we have our next group, multiplication, division, and the remainder. Okay, these are binary operators, and these has lower precedence than these unary operators. That's why when you say A times minus B, I know that this minus will be done first. Okay, before the multiplication, minus will be done because minus, unary minus, is in the higher precedence table than this one. What happens when you say something like A times B over C? This one and this one has the same precedence. They are in the same box. So the precedence rules, they don't apply here. So what am I going to do? I am going to use the associativity rules, okay? If the precedence of two operators are the same, so how am I going to decide which one is going to be done first? Okay, I will use the associativity. In this box, associativity is from left to right, okay? It says that do this star first, then the division later. So this operator will be done first. Whatever it returns will be divided by C. That's the associativity. For all these boxes, it is left to right associativity. There are a few cases. For example, for the case of, let's write the A times B over C. Okay, multiplication will be done first and division will be later. So division C, multiplication A and B. Here, multiplication will be done, then it will be divided by C. I know this, okay, because the associativity is from left to right. How about this part? How about this one? How about this one? I am trying to put them together. Okay, A gets B into H gets C. So which one logically, okay, which one should be done first?
C assigns B.
B assigns C, right? So A assign B doesn't make sense because if I assign B to A, so it will return the assigned value. Am I going to assign C to that return value? That doesn't make sense. So it should be assignment, okay, here A, here another assignment, B and C. They define the associativity for the assignment operator right to left. This is left to right, okay? And the precedence of the assignment operator is very, very low. It is way below all the tables, way below all the tables, okay? So if I have something like this one gets the value of, D gets the value of this one, then my 3 is going to be like this, assignment and D, okay, because this one has a very low precedence, okay. So addition, subtraction, by definition, their precedence is lower than these. So when you are doing the expression evaluation, you'll be careful about that. Insertion operator, extraction operator, or the binary left shift, right shift operators, they are lower than those. That's why when I say C out, okay, A plus B, it is okay because A plus B will be done before this extraction operator, okay? When I do that, it will be like that. But this is dangerous. This is not good. C out, A, okay? This is not good. Why? Because if I do that, stream insertion will be done first, okay? The stream insertion will be done first, this one. And then whatever the value is returned from this one, I will try to do this assignment, which doesn't mean much, okay? Since the C out is not our object, it's something constant, we shouldn't do that that assignment. Either I'm going to get if I am lucky, I'm going to get a compiler error. If I am not lucky, I will not get any compiler errors, and this will run and this will produce some garbage. Okay, that's why we need to know about these precedence tables. And then after that, we have these are logical operators, comparison operators, and these are okay, lower than the others. So I can write stuff like this. I can compare A with C, then I can add A to B and C to D and compare them, okay? So it looks like this will be done last, right? Because OR has a lower priority than the not equal or equal operators. I know these rules, I don't have to parenthesize these. Some people say that better be more careful and be more cautious and do this. They say that this is more readable. Yeah, well, they might be right, it's more readable. But you don't have to, I mean, if you write something like this, I definitely know that, okay, B divided 7 will be done first. So I know this, right? These are by the rules. If I do this, the result will be exactly the same. Some people say that parenthesize it this way, so that it is more readable. To me, this is not more readable. To me, I am seeing that, okay, something is wrong with this statement. Somebody tried to write something else, but by mistake they put a division operator here because If they didn't put the parentheses, they would have been the same thing. So this is more confusing. So when you use parentheses, maybe, yeah, even though it's going to be exactly the same, the results for this statement, I am parenthesizing it to make it more readable. Maybe for this case, yeah, that's true. But for this case, it doesn't make it more readable. And then we have these two AND operator and the OR operator. Good. And at the end, you see, we have our assignment group. As I said, the priority or precedence of the assignment is very low, way at the below, okay? And after that, we have the conditional operator. We will talk about this conditional operator later, okay? It will come. You know what it is. By the way, this is the only operator in CC++ that will take 3 parameters, right? All of them, they will take either 1 parameter or 2 parameters. This one will take 3 parameters exactly. That's why it is sometimes called ternary conditional operator, okay? It takes 3 parameters. See, this is the, okay? This will take this conditional statement. If the condition is true, do this. Otherwise, do that stuff. Okay. So I don't know why I wrote this, but let me erase this part. What? Yeah. Okay. Erase this. I don't wanna confuse you. It will come later. Throw, we will talk about it later. It's a new C++ keyword. You don't have this in standard C98. It was added later. Okay. Then at the end we have the lowest priority operator, comma operator. People don't know about comma operator much, but we have been using this comma operator a lot. Remember these kind of statements? For I starts from 0, J starts from 1, K starts from 3, continue while K is less than 5, and every time you run this loop, increment I by 1, okay? This is a very familiar for statement. 3 initialization statements, and 2 of them are the regular for statements, okay? So these are the comma operators, okay? Comma operators. Comma operator, as we have seen here, its precedence is very, very low. So this assignment will be done first, okay? This assignment, and this assignment, they all will be done before the comma operator. Okay, comma operator. So what does the comma operator do? Let me tell you this. If I have a comma operator, since it's an operator, it has to return something, right? All the operators here, they all have to return something. This returns something, this returns something. Assignment returns when you do A gets the value of 2. What it's going to return? It's going to return 2, right? It's not going to return A. It's going to return a value, assigned value. Everybody has, all the operators, they have to return something, and comma operator returns something too. Comma operator says that I will take 2 parameters, this one and this one, P1 and P2, and I will return P2. That's it. It doesn't do anything. It just says that I will return P2. But before I can return P2, I need to know the values of P1 and P2. Okay? So when you say A gets the value of 2, comma, B gets the value of 2, this comma operator will cause A to get the value of 2, then it will cause B to get the value of 2, okay? And this comma operator will return 2, or maybe I should write, okay? Will return 3, because B gets this value, okay? Comma operator is one of the special operators in C++ that tells that which side is going to be executed first, okay? It says that my left side will be done first and then the right side. This order is defined. This order defined. Plus doesn't say that, okay? when you say multiplication. Multiplication doesn't say that, or let me do it plus A times B, C times D. Plus operator doesn't say anything about which one should be done first, A times B or C times D, okay? I know that both of them will be done before plus operator. That's the meaning of the precedence, but we don't know which one is going to be done first. But the comma operator says that, okay, this is the C rule, the languages rule. A will get the value of 2 and B get the value of 3. I know that, but this one will be done first. This is guaranteed by the language. Okay? So that's the comma operator. And we use this in this kind of cases. When you do the comma operator, this is just a single statement. Okay? This one says that, okay, question for you. Which comma will be executed first? This one or this one? Yeah, left one. Why? Because it has the associativity of from left to right. This one will be executed first, and this one will be executed first. What does that mean? It means that if this one is going to be executed first, okay, so it will assign 0 to I, then it will assign 1 to J. Now this part is done. I am doing the same mistake. How am I going to use? Okay, if I use 5 fingers, okay. So I did this part. What is the result of this part? What is the return value of this first comma operator? 1, right? Because it assigned 1 to J. Then it will ignore whatever it returned. Then it will execute the second part, this part. Okay, and at the end of this comma statement, it will return 3, but we are not using it. We are just ignoring it, right? You don't have to use the return value of an operator. Question for you: if I write 2 plus 7 as a C statement, would I get a compiler error? It's just 2 plus 7. That's it. No, we don't get it because we keep writing these kind of statements all the time. When I do A gets the value of 2, this one will return 2 and I ignore the return value, right? This one will return 9, I ignore the return value. You don't have to use the return value. We keep writing. What does printf function return? What is the return type of printf function? It is integer, right? It is not void. Some people say it's void. It returns the number of characters printed on the screen, on the standard output, right? But we don't use it, okay? We just ignore it. We don't assign it anywhere, okay? So again, this comma returns whatever the result of this last statement is. We don't use it. We don't use it. Okay. By the way, this is the expression tree for the. Well, I mean, these are not exactly true, but for the sake of simplicity and for the sake of telling you what's going on, I can do these kind of approximations a little bit. This for statement has, okay, 3 parameters. Let's say this for. Let's think about this for as like a function. Okay, it needs 3 parameters. The first one is here, the second one, and the third one is here. For us, all 3 of them are not simple statements, but they are operators, okay, being executed. The first one is a comma, okay. The second one is a comparison operator, and third one is a pre-increment operator. Okay, comma, it says, I will do this assignment first, okay. Then it is written like that, okay. Then this expression tree says that, well, I mean, if this is a regular plus operator, I wouldn't know which assignments would have been done first, but comma says that this one will be done first, then this one will be done later. Okay. So this is the comma operator. Yes.
If operation tree is like that, return 3, I think, not 1. Because of
No, the definition of the comma is do the left side first and return whatever the right is returning. It's something like this: a plus b, b plus c. Do this first, a plus b, okay, whatever it returns, okay, used as a parameter for the second one. So when I say a comma b comma c, okay, do this comma first, whatever returns, I just ignore it and return the result of c.
both of commas return C.
No, just one. This one returns b, okay, this one will return b, and this one will return c. Okay, comma ignores whatever is returned from the left side.
Yes, I understand it, but operation 3 seems comma returns commas return. Like,
Okay, this comma is this one, right?
yes,
It will return, this one will return, it will ignore this part, right?
yes,
It will ignore this part, I0 is ignored. This one says that, okay, whatever is, oh, you are saying that this expression 3 is wrong. Yeah, that's it's true. True. I0, yeah. This one is done first. This operator is done first, and this one, I drew this wrong. This should have been, yeah. So all those people of last year, they learned it. Well, they didn't learn anything here. So this one is going to be, so the last one is going to be, the last expression to be, okay, this comma, let me do this way. Okay, this is our comma, and this one says assignment, and assignment I is 0, or I 0 here, J1, and not comma, assignment K3. Okay. So since this is the one done first here, before the other side, this one will be done. It is this part. Okay. So this one will return what? This one will ignore whatever the value is returned here, 0. It will return 1. Okay. This comma will take this 1 and it will ignore it. Okay. It will execute this part, K3, and it will return 3. Okay. Good. Any other questions? Yeah.
Before logical operators.
Before the logical operators. Yeah.
We, I think,
Where?
and or statement, parentheses.
You mean these?
Yes. We cite is same site and or operators left or
Well, they left and then or operators. I didn't talk about them yet. We are going to talk about it in a few minutes. Any other questions? So did everybody sign their names? It is doing the same, still doing the same thing? Okay. Maybe I will print out the attendance sheet and I will bring it in the class. Let's take some break. After the break, we will continue.
Bir şey danışabilir miyim ya? Geçen gün şey yapamadım da. Hocam ayrı matematik dersi var ya.
Evet.
İkinci sınıfın. Ben o derse girdim ve biraz da syllabus'a falan baktım. İlk derste konuştu hocam.
Evet.
Yani çok fazla böyle lisans 2'de ders olduğu için benim için biraz seviyesi şey geldi. Hani onu muaf tutabilme imkanım var mı?
Vallahi öyle değil. Çok kalan oldu dersler.
Ya hocam yapmayın ya. Lisans 2 dersi ve şey.
Tamam, senin için iyi, güzel alırsın derse. Yani geçersin tıkır tıkır. Neyi yapmayayım ben anlamadım. Kalan sensin ben değil ki.
Yani onu ben almak istemiyorum açıkçası. Yani mümkünse.
Tamam, girme öyleyse derslere.
Efendim?
Girme öyleyse derslere. Seçilsin, ben alacağım diyorum. Sen de almayacaksın.
Yani şeyde sorun olmaz değil mi?
Yok yani bu bölüme girip geçmiş yüzlerce kişiler senin farkında. Almak istemiyorum deyince almak istemiyorum.
Yani ben set teorisi ya da function görmenin lisansını göremiyorum yani. Ben daha fazla böyle daha etkili
Senin lisansın neydi?
matematik.
Doğru söylüyorsun o zaman ya. Biz sana fazladan. Evet evet.
Soru dersi biter. Ve lisans
Bizim sen alırsın zaten. Sen alanın dışında ders alamazsın yok. Ona sen bir dilekçe versene hemen. Dilekçe ver. Evet evet. Peki ben de matematik mezunuyum de bölüm başkanlığına. Hayda, ben üyeyim ya. Tamam. Hoca da zaten uygundur diye imzalayacaktır. Bir dilekçe ver. Ona bakalım. Bu dönem açılan başkan kaç tane ders alıyorsun? Sen programlama alıyorsun. Ayrı kalıyorsun. O zaman Türkiye'de sistemleri... orada mı burada mısın? Sonra ne yapayım? Geri mi döndün eve? Bizim Eren de annesi olmuş. Orada İstanbul'a gidecektik. Tam o yağmurda ıslanmış. Onu hatırlayacak. Bilmiyorum ki. Saçma. Ama işte burada şöyle bir olay var. Normalde dönem içinde ders seçerken şey yapabiliyor mu? Hoca onaylarını değiştirebiliyor mu? Değiştiremiyor. Biliyorum onu. Ya mesela şu anda hoca şey yapıyor. Bir sene işte daha değiştiremiyor. Normalde değiştirebiliyor. İşte hocanın yanına gideceksin. İstersen de sen de sen şu an ne taraftasın ya bu arada? O yüzden gelmiyorsun. Tamam. Geleceksin öğleden sonra. NLP kaçta? 1.30'da mı 1'de mi? Ne saçma ya. Nasıl bir oluyor abi? 1.30 olmuş çünkü. Öğlen yemeği var ya o yüzden. Tamam kanka ben de okuldayım zaten. Beni eğitim oraya yolladı. Unuttum şeyde olduğunu. Geç kardeş yapmıyor ya. Bir baktım hocanın yanına gitti.
Mesela dediğim şeyi yapıyorum. Hayır.
Nasıl açıyorduk lan? Emre falan.
Artı bul kanka, artı bul.
Kardeşim bu ne pandemi var,
Şey
çıkar
yapsana.
şunu.
Şu değil mi? Volüm, zoom.
Niye?
Önce bir ayarlara giriyoruz, dur.
Yani mi?
Parlaklık fullesene.
Bekle, oraya gelmen lazım. Sağa kısa kaysana.
Ha?
Sağ tuşa bassana.
Yapım yazıyor orada. Görüntü.
İşte
Ha,
direkt-
parlaklık.
Fulle açıkmış lan. Açık hale böyle.
Bilenmemiş ama.
Fulle.
Do you want? Yes.
Bekle, uzaktan
Bir
bak.
şey değişmiyor.
Karşılıklı.
Bence değişmiyor bir şey bu arada.
Karşılıklı da fulle.
Karşıda full.
Orada iyi.
Aynı değil mi ikisi ya? Dur bir düşüreyim.
Yok, karşılığa bir geç.
Bir dakika.
Oradan anlarız.
Kontrastı full.
Aynı gibi ya.
Oğlum karşılıklı söylemiyorum. Söylesene.
Kontrast. Ben de
Aynı şey değil ki.
Nasıl
Daha
değil?
kötü
Değil
oldu
oğlum,
mu?
karşılık. Siyah beyaz dengesi kontrast.
Öyle bir şey mi? Bu hiç etkilemiyor bu arada.
Ben mi yanlış yapıyorum?
Yok oğlum.
Emre,
Ha?
bu işi etkilemiyor.
Yok,
oğlum.
etkiliyor, aşırı
Etkiliyor
etkiliyor.
mu?
Şu an
Azaldı
alem
mı?
böyle değil
Ben
mi? Aşırı
kör
etkiliyor.
oldum.
Valla.
Ya 100'den sonra çok fark etmiyor da 100'e kadar çok fark ediyor. Sen aşağıdakini at. Lan nereye gidiyorsun?
Kör oldum diyor ya. Neydi o? Profesyonel olmuyor.
100 yap, bırak.
Tabletler çok aç.
Sivrile bırakalım diyor.
Çok yapıyor.
Karşılıklı ayarla biraz.
Çok
Ha?
aç gözünü
Karşılıklı ayarla. Onda fark ediyor.
Ya okunamaz olmasın
Fark ediyor
ya.
mu?
İyi çok kötü oldu.
O karşıtlardan
Hiçbir
iyi.
şey değişmedi ama.
Renk dengesi. Sonra tamam.
Parlaklık kısmı.
Geliyor.
Tamam kaydet herhalde.
Ay çok kötü oldu kanka.
Geri al.
Okumuyor. Karşılıklı kısmı.
Ama karşıtı ellemedi. Ben saçını getirdim. Parasından bir şey.
Neden böyle? Evet.
Ellerde eli. Şimdi
Yine kötü lan.
aynısı değil mi?
Daha iyi.
Daha mı kötü?
Parlaklık kısmı ya, parlaklık kısmı.
Ama aynısına getirdim parlaklığı. Daha mı kötü şu?
Ya bizim sözlük çocuğuna
Ha?
sayılır.
Emre daha mı kötü?
Kanka.
Oğlum cevap versene daha mı
Bir
kötü
şey
daha mı iyi?
değişmedi oğlum.
Ha? Aynı
Ay
değil
şu an
mi?
iyi.
Aynısına getirdim şu
En
an.
son yaptığından iyi.
Oğlum aynısına getirdim. Ellemeden öncesine
Gel
getirdim.
uzaktan bak oğlum.
Ha?
Gel eline bak, patlayacak.
Evet cevabım bu.
Oğlum aynısına getirdim.
Nasıl daha kötü oldu? Daha ne öyle oldu?
Bunları kendine ekleyin. Bunu oğlum.
Aynısı oğlum.
Arkadakiler kör oldu.
Nasıl bir şey ben anlamadım.
Oğlum Emre aynısı ben.
Oğlum biliyor musun?
Daha kötü bir şey gibi.
Default'a mı ayarladın?
Ellemeden öncekileri
Parlaklığı
getirdim.
150'ye almış ya. Hiçbir şey yok. Aynen onu herhalde.
Saz remix ne demek? Bak açıyor. O kavgayı açayım.
Biz geliyoruz gerisine.
O büyük bir ihtimalle zaten
Görüyoruz
bizden sonra.
gerisine.
Onun normalde şeyi yok. GCC'de uyanmak şeyi.
Hikaye çok kötü diyor Abdullah. Söylentiler de.
Niye sevmedin?
Ben orada kalan buldum. O hafta sonu dedim anlat program nasıl dedim. Yok adam kesiyor falan dedim. Böyle demez oğlum işte. Her ay sonu koordinat olur. Etkinlik olur. O da doğru.
Bunlar söyler misin?
Yok onlar bitti demek.
Böyle de olur, sohbet vardır yani.
Sohbet değil oğlum bu başka.
Ne farkı var?
Her ay sonu
Ha küçük oda, küçük oda.
konferans olur. Bu kampa götürür seni her ay sonu. Hiç var mı? Mesela devim var diyor. Millet geldi yani.
Diğerleri sadece kayıtlandı.
Reis geliyor. İlk önce geçiyor mangala gidiyor. Ayak olur.
Burada saati varsa ben alırım. Saati olmasa
Piyasa ekini biraz çekiyor. Masalar değişmiş. Bir 11 kişi bir yazı beklentisi. Adamlar bizim hatta gelmek istedim.
Okay, so I handed out the attendance sheet. We are doing the manual attendance for today, but for tomorrow we are going to find a solution for that online attendance thing. I think I'm going to use a form or something like that. Okay, so these are our, again, we are talking about the expressions and we are talking about the operators. We talked about the operators that continue. Yeah, I think you are, what was your name? Sorry, Ahmed. Ahmed asked a question about this short circuiting thing. Okay, in C and C++ we have short circuit evaluation. Short circuiting is done for AND operators and the OR operators. Short circuit says that, okay, again, this is a special case only for these operators. I will do the left part first. For the AND case, if left part is true, I am going to do the right part. If it is false, I am not going to do the right part because it doesn't make sense to do the right part, okay? So for the AND case, do the left part. If it is true, I will do it. If it is false, I won't do it. For the OR case, I will do the left part. If it is false, I am going to do the right part. Because for the OR, you know, I mean, if this is false and this is true, then I'm going to return true. If this is true, then I'm going to return true anyways. If this is false, I am going to false anyways, okay? That's what AND and OR says. This is called short circuit evaluation. To be able to do that, okay, the C and C++ says that, okay, I'm going to specify the order of evaluation. Remember this when I say plus A, okay, times AB times CD. Remember, the plus doesn't care about A is this multiplication is done first or this multiplication done first. A plus doesn't care about it, or many operators of C, C++ doesn't care about it. This is not the case for the AND and OR operators. They do the short circuiting. They say that definitely left side first and right side later. So why are we talking about this? Is a performance issue, right? It's a performance issue, but if we have such cases like this, that's another issue, because this one will do this comparison first. If it is false, y will not be incremented at all, okay? If it is if it is false, y will not be incremented. If it is true, then y will be incremented, and if the incremented value is non-zero, then it's going to return true. Okay? So the rule is simple. Do the short circuiting. If there is an AND operator or OR operator, do the left side first. Depending on the result of the left side, I am going to do the right side or not do the right side. Okay? So since I have this y plus plus in here and it has a side effect, it is incrementing y by 1. So depending on the value of this x, Okay, y sometimes will be incremented and sometimes it won't be incremented. Okay, so be careful with these kind of statements. Don't write these kind of statements. These are very confusing. It is difficult to write, difficult to debug, and it is difficult to read for your fellow co-workers if you hand over your code to them, and they will have some difficulty reading these kind of codes. Okay, so that's, I mean, the fact that we have short circuiting is not that important. I mean, the compiler might optimize it and that kind of stuff and etc. We are not talking about the performance here, not executing the second part. We are talking about writing the correct code. Okay. Can you stop working on that computer? What are you doing on that computer? What is he doing? Is he watching YouTube? Is he watching YouTube, that person? What are you doing with your computer? You are not listening to this class. You are not, right? Turn it off. Okay. I am talking about short circuiting. He is laughing. This is not funny. Okay, good. So we talked about short circuiting. Ahmed's question. That was it. And yeah, any questions on this? If there are no questions, then I will continue. C++ introduces this new enumeration type. Okay, you would say, I have a new type. Its name is days. This new type, like an integer, integers, remember the integers, if I have a 16-bit integer, it can take values from minus 32,000 to plus 32,000, etc. This days type can take values only from one of these. Okay, I am defining the set of values that days can take. Okay, and now I am defining a variable of type days. Days is a new type. D is a new variable. It's like integer I, days D. I can take integer values from some minus some value to plus some value. D can take, okay, one of these values, Sunday, Monday, Tuesday, Wednesday, etc. Okay, and here is how you assign a value. You will say, inside the days class, there is a Tuesday value, and I'm assigning it to this days D. Okay, so this is called enumeration types, strong enumeration types. Well, we had the kind of enumerations in C. Remember the enumerations? Did they tell you about enumerations in C? They did, right? This is a stronger one because in C, those enumerations are simply integers, right? They are no different than integers. In C++, they are not integers. They are definitely full-fledged types, and you wouldn't say if D is 0, then do this, etc. No, you can't say that because D isn't an integer. You will say if D is Wednesday, then do this, etc. Okay, so I define two of them. One is a days type, the other one is a weather type, rainy or sunny, and this is how you do the assignments. Well, for the integers, we can do many things, right? For the integers, I can do the assignment. Okay, I can do the plus operator, minus operator, division operator, etc. For this type days, all I can do is the assignment, comparison, and that's it. There are no unary or binary plus minus operators, multiplication stuff, and etc. Okay, but it's an enumeration, and you know where the enumerations are used. Sometimes you like to enumerate over some days is a good example. I mean, there are 7 days, and instead of giving each day a number, an integer number from 0 to 6, I would give these unique special constants to the days. And if I have a mistake, like use something other than these 7 constants, then I would get an error message, and that would be very helpful. Okay, it's more readable, etc. So this is a C++ 11 feature. It is not available in C++ 98. So if you compile your program using G++ compile something, you will get an error message. You have to say G++ minus std minus std C++ 11. You should say that. Otherwise, you would get an error message. Yes?
The illegal statement gives a compilation error.
Yeah. These are not integers. In C, we thought them as integers, and we use integers instead of your enumerations. That wasn't good, because I can assign a minus value to it, right? And that's not good. In this case, you cannot assign any minus values to it, or any illegal values to it. Branching is the same as before. I am not going to talk much about it. Remember our structured programming example, structured programming initial stuff. This is the branching condition. If it is true, do this. Otherwise, do this, right? Okay. So this is the branching case. There is exactly one entrance to this block statement. Okay, enter from the top, exit from the bottom of this statement. And I can replace each of these statements with any compound statement. And this is all branching stuff. And we talk about this when you do the if stuff. Okay, sometimes we do this kind of an error. If x get the values of 12, do something. This is not a compiler error, but I think G++ has a switch. It says, give me a warning message if I am doing something like that. Okay, I think G++ has a switch. When you try to compile something, it doesn't give you an error message, but it gives you a warning. Are you sure about this? Okay, good. We talked about this. Of course, nested if statements are possible, and they are within the rules of structured programming. If, okay, for the else part, there is another if. For the true part, you might put another compound statement. These are nested statements. Sometimes we do this nested if-else stuff. If something, do this. Else if, do this. Else if, do this. And then the else part. I mean, indentation of this multi-way if-else statement is a little bit different. Usually, I mean, when you do this, if something, then do this. Okay. Well, if this is an if statement, then it should be like that, right? I mean, I keep doing this indentation over and over and over again, but no, we don't do that, okay? It looks ugly. Instead, we do this. It is understandable. Everybody writes it this way, okay? So this is multi-way if-else statement. I am not saying anything new in here, actually. This is all defined by this, okay? In the else part, I am writing another if statement. In the else part, I am writing another statement. All I am saying is that if you are doing something like that, don't use this kind of a indentation style. Use this one. This is more readable. Okay, we talked about the switch. Some people, structured programming people, they don't like switch at all because switch has to has breaks in it, right? And there is a default part in that too. But some other people say that, well, as long as we know what we are doing, why don't we use it? I'm not going to talk about switch much. So I am sure many of you, the first time you use switch statement, you forgot about this break statement here. When you forgot the break, you know that, I mean, if case is 1, if there is no break, it will continue with case 2 and etc. You know those kind of errors. Well, these are C stuff. I am not going to, again, I am not saying that they are not important. They are important, but they are not our topic. I will skip it. Break, again, is a problem, and the default part is a problem. You need to be careful about those. Okay, let's talk about this conditional operator. Okay, these two statements are exactly the same. This one and this one. This one says that if n1 is greater than n2, then max will get the value of n1, otherwise max will get the value of n2. This one does the same thing too. It says that, okay, it says that compare n1 with n2, okay. If n1 is greater than n2, then return, see this ternary condition operator, this ternary condition operator will return something. This is an operator, right? And whatever it returns, if my pen works, okay, whatever this ternary condition operator returns, it will be assigned to max, okay? And this one says that if n1 is greater than n2, I am going to return n1, otherwise I am going to return n2. And this will be assigned to max. By the way, I think I should put a parenthesis in here, right? Because the precedence of assignment is greater than the ternary condition. Is that correct? I don't remember. Do you guys remember it? Yeah, ternary condition operator comes later. So I need to parenthesize it. Because assignment is before that, right? Assignment is going to be done first. Okay? So I parenthesize that. By the way, I don't need this parenthesis, this one, because greater than operator has a higher precedence than the ternary condition operator. Anyways, these two statements are exactly the same. Okay? And this one, okay, let's talk about it. The comma operator, or operator, and operator, and ternary condition operator, these are the operators in C and C++. These are the only operators in C and C++ that define which side of these operators will be done first. Okay? Comma says that do the left side first, then the right side. This one and this one says that do the left side first, and depending on the results, you are going to do the right side or not. And this one says that, okay, do the left side first. Depending on the results, you are going to do either the second one or the third one. Okay? Other than these 4 operators, all the other operators, they don't care about the left and right. Okay? We don't know which part is going to be, we don't know which part is going to be done first. Okay? You have a question?
If you didn't put parentheses, what will the assignment?
Oh, yeah. Well, let's look at it. I mean, if I didn't do it, okay. So what is the precedence, operator precedence? Precedence says that I have how many operators in here? If I don't, let's okay, max gets n1 greater than n2, n1, n2. Okay. How many operators do I have in here? 1, 2, 3. 3 operators, right? So when I look at the precedence table, this one will have the highest precedence, right? So I will do this. I will do this first. This one is going to return a Boolean. Okay, this one is going to be a Boolean. Then I have this Turner condition and the assignment. Assignment has a higher priority, right? This Boolean is going to be assigned to this max. If it's an integer, you will get a compiler error. It's going to say Boolean to integer is a problem. If it's a Boolean, it will be assigned. Okay, it will be assigned. That assignment result will be true or false. If it is true, it will return n1, otherwise it will return n2. Okay, so it depends on what the type of max is. Okay, yeah.
During runtime, is there a speed difference between if statements and else?
Well, they are exactly the same. There is no, in terms of what? What do you mean difference?
Compiling or running the program.
They are exactly producing the same assembly code. I mean, some people say that, I mean, this is more readable, this is less, but C people, they know what this ternary condition operator means. Sometimes it is writing this 4 or 5 lines of code. Well, I mean, why don't we write just a single line of code instead of writing 4 lines of code? They say. Okay, I mean, if I am writing this statement, I wouldn't write it this way. I would write it this way: n1 greater than n2. Okay, max get the value of n1. Otherwise, max gets the value of n2. To me, this is more readable. Okay. No parentheses. I know that the ternary condition operator will be the last one, right? Okay. So it's going to evaluate first, and if this is true, this will be done, and this will be last. Yeah.
When we don't use the parentheses, what happens to n1 and n2? Right off the question mark.
Well, I don't have any parentheses in here.
No.
You mean here, like this?
Yes. What happened to n1 and n2? Right side of the question mark.
Right. Well, I mean, n1 and n2 are variables. Nothing happens. I mean, they are just variables. I just return. Is this a, what did we say? 1 plus 2. Is this a valid C expression? Yes. It just returns 3 and it is ignored. How about this? Is this a valid C expression? Yes. It's just 3. So when we do this, if this one returns n1, just it is returned, and if it will be ignored. Okay. Any other questions? Yes.
What happens if we have nested ternary operators?
Well, if you write a nested ternary conditional operator, including yourself, nobody will understand your code. Okay. But if you like to know what happens, sometimes it gets confusing. Just convert your code to this version. Okay. So this one, there is an if statement. Okay. If this happens, do this, otherwise do that. So write an if statement. Okay. And try to understand. But writing a nested ternary conditional operator statement is not a good idea. This is only, I mean, if there are 2 things that can achieve the same thing in C, C++, you might ask why there are 2 different ways of achieving the same thing. The answer is for convenience. For human beings, sometimes we like to write it that way, sometimes we like to write it the other way. Okay? So if you are using this convenience tool to make things more complicated, then you are not on a good way of writing your programs. Okay? Don't do it. Okay? Don't use the ternary condition operator for complicated if-as structure. Okay? Loops are exactly the same as in C. We have the while loop, we have the do while loop, we have the for loop. Of course, most of the time we don't use do while. Most of the time we use while and for. As you know, whatever you can write with while, you can write it with for, and whatever you can write with for, you can write it with while. I cannot say the same thing for the do while, because do while the loop will execute at least once, right? So it is a little bit different. So again, it's like it's going to take maybe 2 or 3 weeks of C course lectures to tell you about the loops, but now I am skipping it because you already know that. Comma operator, I already did that. Okay. So don't write such an expression. It is confusing, but that doesn't mean that we shouldn't discuss about it. Let's see. This one says that the presence of comma is very low. That's why I parenthesize it. Okay. Instead of doing this assignment, do this comma first. Okay. Comma says that execute this part first, assign 2 to first. Since I have assigned 2 to first, the value of first will be 2. Okay, plus 1 is 3. The value of second will be 3. And this comma will return 3, right? And I will assign that 3 to first. So I assigned 2 to first, then I am assigning 3 to second and first. Because comma guarantees the order of expression evaluation. Again, don't write such code. This is I mean, we don't use, but there is one suggestion. Whatever type of programming you are using, try to write understandable code, okay? Don't try to be original. Don't write original code. Don't tell anybody that I write a single line of code, nobody understands it but me. That's not a good thing, okay? Whatever you are writing, it should be very easily understood. I don't have to be very smart. I don't have to be very experienced to understand your code. That's the way we write our code, okay? Don't try to write, well, I mean, I'm going to write some code that whoever reads it, they will think that I am a very smart person. No, that doesn't make you smart, okay? That doesn't make you smart. It just makes you the opposite. Try to write understandable, simple code, okay? By writing your code that way, your final product will be smart. Okay, so we already know about this. Some people put a semicolon in there, right? This is the while statement, this whole statement. While statement doesn't end here, okay? It ends there, and we don't put semicolons at the end of the curly braces, okay? If you put a semicolon in here, there is an infinite loop. If response is not 0, then continue running this loop, infinite loop. Okay, so this is important. If this is your intention, really, if this is your intention, then write your code this way. I like to run an infinite loop around this variable r. If r is not 0, then keep running this loop. We call this an infinite loop, and sometimes we write these kind of loops. So what is the meaning of infinite loops? I mean, why do we write infinite loops? Well, I mean, if you are writing your infinite loop to be really an infinite loop, then you are a bad programmer. We usually write the infinite loops so that we are going to be in this loop until something else happens. But you are saying that what can happen to R because nobody is changing it. But in a multi-threaded environment, multi-process environment, you are not the only program running that can modify R, okay? Maybe there is another thread running and R is working on that R too, that other thread. Once the other thread changes the value of R, now you are break out of this loop and you will continue, okay? This is done a lot with the parallel programming. Okay, so we talk about this. In embedded systems, well, I mean, there are some computers with no operating systems, they do just one thing. It's a computer, very simple computer. It just does one thing. And whenever it starts running, it runs a loop like this. While true, gets the input, and process input. That's what that program does, okay? Gets the input and processes the input and does this for its whole life until the power is turned off. And it doesn't do anything else. In that case, again, for the embedded systems, it works like that. This might have a this remote control might have a small operating system in it, or might have a small computer without no operating system. All it does is it waits for the inputs, push a button. Whatever the button is pushed, it does something accordingly and runs into this loop, gets the input and processes the input and nothing else. And it continues doing this for its whole life until the battery is out, right? So for these kind of cases, these kind of infinite loops are possible. Yeah. And in fact, my own computer, this computer is running some kind of a loop like that too. My computer is sitting idle most of the time. It is waiting for the input. What is the input? It could be a keyboard input, mouse input, pen input, or the input from the wireless receiver, input from the Ethernet, input from somewhere else, and it just responds and keeps running this infinite loop. Okay, so infinite loops are used for different purposes. But if you are, you need to be careful about infinite loops. If you really like the infinite loops, do this. Okay, don't do that. That's confusing. That's difficult to read, and probably it's an error message. Somebody's asking a question?
I asked a question about controller command.
Yeah.
So it uses energy when nobody pushes the button.
I didn't say that it has a computer. It doesn't have a computer, but I was trying to make it simpler. Yeah, that's a problem. If nobody is pressing a button, why should it run a loop? Well, it doesn't exactly happen that way. It gets stuck in the air. It is waiting for an interrupt to happen. So it is a little bit smarter than that. And our computers, they don't do it either, okay? If there is no input, it doesn't run this loop using the 100% of the CPU power, okay? It is smarter than that. If there is no input, it just idles the CPU. And it gets help from you are going to learn this from when you take your architecture course and the operating system course. Okay, good. Break and continue statements for the flow of control. Remember, I can use break and continue in our while loops and for loops. Okay. But we say that these statements violate the nature of flow. They are not as bad as go to statement, but they are kind of friends of go to statement. Okay. Nested loops, like with the if statements or another statement, I can write there nested loops. A loop inside another loop. That means what? For each iteration of the outside loop, I am running this whole loop for each iteration. So I am going to run this outer loop 5 times. For each iteration of the outer loop, I am running this 5 times too, from 7 to 2, right? Okay, we already know this. I am not going to talk about it. Good. So I think I did this one, and this one. Let's talk about file input. Okay, I guess you spent maybe 2 weeks in C to learn about if switches and etc. Maybe 3 weeks in C to learn about loops and etc. So I did that in a single hour or 1.5 hours. Let's talk about the file input, and for the files maybe you spend a week, but I am going to do it in 10 minutes. Okay, so files are files, no different. Let's talk about the text files. Let's say I have a file like this. It's a text file, play.txt. And inside the text file, I have this score, a computer game score. It is like 100,510. And the name of the guy who did the score, Gordon Freeman. Okay, I am going to write a C++ program that opens these files and reads this integer and reads this name and prints it on screen. That's what I'm going to do. Okay, and this is the program. Where is the program? This is the program. Yeah. We are going to use strings. Remember our IO stream for the C in C out, and there is a new header file, F stream, file stream. If you are going to open files, you need to include this header file, F stream. Okay, so main, 2 strings for the first name and the last name, and for the score there is an integer. And here is our new type, F stream. It's a new type defined by C++ standard. Okay, inside this F stream header, and I am defining a new variable, input stream. This is, I mean, line 9 might be a little bit complicated or confusing. When you try to write the same program yourself, you will get confused. Am I going to write input stream first and F stream later and etc.? But if you get confused like that, always remember line number 8. I am defining a variable named score, is typed integer. I am defining a variable named input stream, its type is F stream. I am going to define a string named first name, its type is string. Okay, so line 7, 8, and 9 are regular declarations, variable declarations, local variable declarations. 3 different types. We knew integer from the beginning. Okay, we just learned about strings and we liked them a lot last week. Now we are learning about this fstream class or fstream type. Okay, like I can say, remember the string functions that I showed you? You could say cout first name dot length, right? Length is a function of this string, right? Like that, this fstream class has functions. One of them is open function. I am saying that input stream dot open this file for me. The name of the file is player.txt. Open it. It's like fopen, right? Remember C, in C we have fopen. It opens a file. You might say that, okay, with the fopen we specify options like I am opening this for reading or writing or for creation or appending, etc. We have those kind of options here too, but we are keeping it simple for now. Okay, open player.txt. I opened it. Okay, now the file is open, I am assuming, and I am reading a single integer from this file using the stream extraction operator. Remember the stream extraction operator? We used to extract values, extract data from the keyboard. Now I'm extracting it from the file, input stream file. Okay, so it is exactly the same stream extraction operator that I used extracting from cin score and input stream extraction score are very similar statements. Okay, and then remember our file structure is like that. There is an integer and there is a string and there is another string, and then I am reading two strings. I read them, okay, and now I read three things: an integer, a string, another string. And I am sending these to the standard output, cout, like name is this, last name is this, okay, and the score is this. And of course, like I opened it, I am closing my input stream, like fclose. So you might say that these look like fscanfs, right? Remember fscanf? This is an integer fscanf. These are like character array fscanfs. And this is fopen and this is fclose. Okay? So all of that scanf, fscanfs, fopens, fclose, they are all now part of the same class, fstream class. If you look at the documentation of fstream, you are going to see many functions that you can use to manipulate files like reading, writing, and etc. So that's it. That's how you read a file. And it is not that difficult to figure out how you create a file, how to write a file. How do you write to a file in C++? You use stream insertion operator, right? Not extraction, but stream insertion. That's it. That's why we say that C++ kind of languages, object-oriented programming languages, they are very useful to write reusable code. Why? Because once you know that input stream is an F stream, it looks like a regular standard input-output thing, right? So I can use the stream insertion and extraction operator, and your guess is right. It works that way, okay? You don't have to read the documentation, whole documentation, to see how you perform that operation. And if you write a class like fstream, very similar to fstream, use the same convention, use the stream insertion extraction operators so that your customers can easily reuse your class in their projects. Okay, so that's the whole thing. Exercise for you. Go to c++.com and read fstream class. See what kind of functions it has. Okay, what kind of new additions it has in C++ 11 and 17 and 21 and 24. And tomorrow, I think I will start the chapter number 3. Okay, where is my attendance? Attendance sheet? Is it done? Not yet.